Part A should have been pretty straightforward in general. Part A was just asking you to find the area of the region between those two functions. So the only part of that that you might have, hopefully not, but might have struggled a little bit with was figuring out which function was the upper function and which function was the lower function. You should be able to figure that out pretty easily, that this is 2x squared, so that's got to be concave up, right? It's got to open up. So the lower function is the parabolic function, and the upper function is the cosine function. And they gave you an intersection point at x equals 0. They gave you an intersection point at x equals 2. So that makes life easy. All you got to do is integrate the cosine function minus the other function from 0 to 2. So part A is an integral from 0 to 2 of, what was that? Was it 4 cosine pi x over 4, I believe? And then the parabolic one, what was the parabolic one? 2x squared minus something minus 6, minus 6x? Yeah, minus 6x plus 4. Okay. dx. Everybody good with that setup?
Yeah.
Okay, so that setup right there, just itself having this right thing in the integrand here is 1 point. Then you needed to integrate it. You got 2 points for integrating it properly. So 4 cosine pi x over 4 should become 16 over pi, or negative, no, integral of cosine is sine, 16 pi sine of pi x over 4 should be the first half of the integral. And then this one, that should be minus 2/3 x cubed minus the negative 6x is a plus 6x. So we'll integrate that to become plus 3x squared. And then minus the 4 should become a minus 4x. Everybody good with that?
Yeah.
Okay. And so getting this was worth 2 points. And then you just evaluate. So we got 16 over pi. This becomes the sine of pi over 2, which is just 1. So that's just 16 over pi. And then we got minus, this is, what does that become? Minus 16/3. And plus 12. And minus 8. And then minus, I plug in 0, sine of 0 is 0, so that's just 0, and all these other terms are 0. So we're just left with 16 over pi minus 16/3 plus 4. And if I take 16/3 and add 4 to it, that'd be adding 12/3, so that'd be 16 over pi minus 4/3. And that was your fourth point. Any questions on that?
So there were 4 points to this one. That second one was 2 points.
Part A was 4 points. Part B actually was 3 points for this one, and part C was 2 points.
Oh, okay. Will it always usually crack down to around 9 points per
It
total
will always
problem?
be exactly 9 points.
Okay.
Every free response question will always be 9. Yep. Any questions on part A there?
Mr. Bachelor, what if
Yep.
I break up the integral in the second part? So I had the sine as the first kind of integral minus the oh god the quadratic function as the second part.
What do you mean? You had 2 separate integrals, or?
Yeah, I broke them up using
that's
our
fine.
rules. Okay.
Yeah, that's fine. You can do that. That's no problem at all. Any other questions, anyone? All right. let's take a look at part B. So part B, we want to write but not evaluate an integral expression that gives the volume if we take this and revolve it around the line y equals 4. So I had a few different people asking me about part B of this one. If we take this region and revolve around this line y equals 4, that's going to give us washer cross sections when we slice it vertically. So the outer radius is the distance between 4 and the lower function, and the inner radius is the distance between 4 and the upper function. And so we know that this full distance here is 4 units, right? Because that's y equals 4. And I probably should have drawn this over a little further just so that I had more to look at here. But we'll call this, that's r. This distance is just the distance up to the parabolic function. So that's just f of x. And this distance is just g of x. So our outer radius should be 4 minus f of x, and our inner radius should be 4 minus g of x. So we should have pi times an integral from 0 to 2 of 4 minus, and let's see, 4 minus f of x was the parabolic function. So 4 minus 2x squared minus 6x plus 4. All of that squared minus 4 minus the other function, which was what, 4 cosine pi x over 4 squared dx. And that was it for that one. You got 2 points for having the correct stuff on the inside, and 1 point for having the correct limits and constant on the outside. Any questions on part B?
If you simplified the first part, you would still get full credit, right?
As in you distributed out the 4?
Yeah,
Minus
like the
this
4s
4?
cancel, so you could just,
Yeah, that's fine. There's no reason that you need to do that. You don't need to do that. They won't, I mean, this would have given you full points right here. But if you want to simplify it, go for it. My recommendation is if they tell you not to evaluate something, don't bother to simplify it, because otherwise you just have a chance of making an algebra error. But it's up to you. All right, part C. Yeah, sorry, any other questions on B? Everybody good there? All right, so part C, we've now got the region R as the base of a solid, and that the cross sections perpendicular to the x-axis are squares. So sticking straight out of here, we have squares, and the area of one of these cross sections should be the side length squared. Right, this is S, they're all S. The area of that square should be S squared. And so all we have to do is figure out what S is, and S should just be the distance between the two functions, which is g of x, right, or cosine function, minus f of x. And I don't think they asked you to evaluate this one either, right? But don't evaluate. And so part C should just be an integral from 0 to 2 of g of x or cosine pi x over 4 minus f of x, 2x squared minus 6x plus 4 squared dx. And for that one, they just gave you 1 point for this and 1 point for the correct limits on it. Everybody good there or no? Any questions on any of that?
Nope.
All right, let's take a look at this one. So this one was a calculator question. This is the area volume one they had in 2014. So we're working our way up to the more recent ones. First thing they want us to do is find the volume of the solid generated when that region R between that quartic function and the horizontal line y equals 4 is revolved around y equals -2. So if I'm going to revolve this around y equals -2, we're going to clearly get some washer cross sections here if we slice it vertically. So our outer radius, if we're going from here to here, those were supposed to be at those intersections, here to here, our outer radius is always the distance from y equals 4 to y equals -2. Our outer radius is always 6, and our inner radius is always the distance from y equals -2 to this function. And so that ought to be 2 units plus f of x units. So our inner radius ought to be 2 plus f of x, and our outer radius ought to be 6. So we should end up with an integral. That should be pi. It should be our integral, should be 6 squared, or 36, minus our, what was our f of x function? X to the 4th, some sort of cubic, right? I mean 4th degree, minus 2.3x cubed plus 4. Plus 2 squared dx. And then we need to find our limits. So we know one of those limits is going to be 0. And how do we find the other limit?
Use your calculator to find the intersection.
Yeah, so we can. We know that we need to set it equal to 4, right? So x to the 4th minus 2.3x cubed plus 4 needs to equal 4. You don't necessarily need your calculator for that. If you wanted to use it, you could. But you can just factor out the x cubed. Right, so x would be 2.3. But your calculator should have also given you 2.3 if you did it using your calculator. And then all you got to do is use your calculator to evaluate that integral. What did that integral come out to be? Hopefully you got 98.868. That sound right?
What did you get for the inner radius again? What was that measurement?
The function plus 2. F of x plus 2. X to the 4th minus 2.3x cubed plus 4 plus 2.
Okay.
Yeah, so give me 1 second. There was a long question. I'll read it in 1 second. I just want to tell you guys real quick. This was worth 2 points. The limits and the constant there were 1 point. And the final answer was a 4th point for part A. And let me see here. In the calculator question, when you find your integral, it asks to solve and find the volume. Yeah, I mean, if you prefer simplifying things, you can. It just sort of depends on your comfort level with typing stuff into your calculator, because sometimes if you type something like this in, you might mess up with parentheses because you got to put parentheses here and here around it and all. Well, actually, not around it. It should be around here and this is separate because of like how the parentheses go in. I normally just type it in without simplifying it. I mean, I'd type in +6 instead of +4 +2, but I probably wouldn't bother to do, I probably wouldn't bother to expand x to the 4th minus 2.3x cubed plus 6 out squared and then combine it with 36. I don't think I would do that. You can if you want, but I recommend just being careful about how you put it into your calculator. Does that answer your question? Or is that helpful at all? Okay, cool. Anybody else, any questions on part A there? All right, part B. Now our region R is the base of a solid. Each cross section perpendicular to the x-axis is an isosceles right triangle with one leg in the base. And we want to find the volume of that solid. So the area of that cross section ought to be 1/2 of the base times the height, which in this case is just 1/2 that base squared. And what is that base value? What does B equal? Should be the distance from 4 to f of x. So that should be 4 minus f of x. Everybody good with that? So we should have an integral from 0 to, what was it, 2.3 of, put your 1/2 inside or outside, whichever you prefer, and 4 minus your function squared. And when you're writing it out, you don't even have to write out the function. If they've defined this function as f of x, you're welcome to just write 4 minus f of x squared dx. And that'd be perfectly acceptable. And what did that come out to be? 3.574, I believe. And this one was 2 points for having the right integral and 1 point for having the right answer in the end. Good or no?
It's an isosceles triangle, so why is it the side lengths?
Well, that's what an isosceles triangle is, right? Base times height. Base equals the height if it's isosceles, right?
Sorry, my bad. So,
Everybody good there with B now?
Yeah.
All right. And here we've got similar to the one we looked at before. We got a vertical line though. X equals K. That divides this into two regions with equal area. We're going to write but not solve an equation involving integrals that gives the solution to K. And so what's the area from here to K? From 0 to K, that should be half the area, right? And that integral would look like 0 to K of the upper function minus the lower function. And we just want to set that equal to an integral from K to 2.3 of the same thing. If we set those two equal to each other and integrated and solved for K, we should get the value of K that makes that true. And they gave you 1 point if you had one of the integrals, and then they gave you 2 points, a second point, if you wrote it as an equation and set the two integrals, the two correct integrals equal to each other.
Could you have done it so that you set the integral on the left equal to you finding the area, the integral of the entire area divided by 2?
Yeah, if you had done that, that's fine too. But since we hadn't already found that, like in that previous problem, we did a couple days ago, we'd already found that area, so we just set one of the integrals equal to half of it. In this one, since you didn't actually have that area, you didn't have to do that. You could have just written both integrals and set them equal to each other. But you could have found that area, divided it by 2, and set either one of those equal to it, and you would have still got both points.
Would we actually need to like find the area divided by 2 and like actually solve that out, or could we just write it out since it says we don't need to like solve the equation?
If you were finding the area of the whole region and setting half of it equal to one of these, you would need to find a numeric value for that.
Okay.
Yeah. Any other questions here for part C? All right, let's take a look at this one. You got another area and volume calculator one here. You guys all make it through this one all right? Hopefully so.
Yeah.
All right, so we're looking for the sum of the areas of regions R and S. And using a graphing calculator, it probably should have been pretty clear to you which function was above the other function for the different intervals, right? The one that's at first above and then below, which function is that one that I'm tracing here?
The fourth root one.
Right, that should be g of x. So just by pumping those into your graphing calculator, you should see that. That's g of x, and then this one should be f of x. And you needed to find the intersection point, so make sure it didn't give us the intersection point between the two, right? No. So you would just go in and set for part A. First off, you do 1 plus x plus e to the x squared minus 2x equals x to the 4th minus 6.5x squared plus 6x plus 2. And you would have gotten that those intersect, obviously at 0, 2, and 2, 4 that they indicated. Also, when x is 1.032832, and you would have then plugged that into either one of those. Oh, actually, it probably gave you the y value also. So y was equal to, we'll just put it down as 2.4, just in case we need it later, 401108. And I'm going to define these as A and as B, just so that I don't have to keep writing these numbers out. And you're welcome to do this anytime. If you have like a long decimal, call it A and call the other one B. And then when you write out your work, just write A and B if you don't feel like writing out the number each time. And make sure that when you plug these values of A and B into your calculator for the integrals, you don't round this to 3 decimals. Wait until the final answer to round. So our area should have been, for R, G minus F from 0 to our A value. So 0 to A of G of X minus F of X dx. And like I said before, you don't have to actually write the functions in there because they've defined them. And then we're going to go from A to 2 of F of X minus G of X dx. And should have come out to be, this time you can round it at the end, 2.004. So that was worth 1 point. This was worth 2 points. And having the correct limits here of 0 to a and a to 2. So getting this value essentially and properly plugging it in here, 0 to a and a to 2. That was worth a 4th point for part A.
Would you have to shown like, when, can you go back one page?
Mhm.
Would you have to shown that original like 1 plus x plus e to the x squared minus 2x equals the whole other function and then show that x equaled that? Or, cause I just plugged it in on my graphing calculator and I didn't like write out the equation and then said like x equals blank. Like I just plugged it into the limit of integration. Would that be an issue?
Yeah, it would be. Make sure you always write, if you're using a calculator to solve for an intersection point, write out the equation that you're effectively solving using your calculator. So you're solving this equation, say, this is what I'm solving, this equals this at these values. And then
Okay, so would that be like minus 1 point or something?
it sort of depends on who's grading it and also the problem and how they have the exact guidelines written for the scores. I would, for this one, I would probably say you'd be okay, but for some other ones, I would probably tell you it would get taken off. So just make sure you're, anytime, I mean, that's kind of like a rule here that we want to sort of get used to, is that anytime you use a calculator to do anything, write out the equation or the integral or whatever it is that you're having the calculator solve, and then you can just put the answer as long as you put this there first. So same thing here, like I can write all of this, this is all great, and get my answer, but if I don't write all of this stuff out, I'm not getting 3 of those 4 points. I might get a point for getting the right answer, but I'm not going to get the rest of it because I didn't write out that integral.
Okay,
Even though the question just says find the sum of the area of the regions, they still want to see how you got that number. And then, I mean, they know you're in a calculator section. They know that you used a calculator to get this number, and they know you used a calculator to get the value of A, but they want to see that, you know, you actually found it correctly and using the right algebraic equation, not just looked at the person who was 3 seats over from you and wrote down some number.
okay.
Yeah. All right, any other questions on part A? All right, let's take a look at part B. So part B, we now are just talking about region S. So the one with F above G. And we're saying that the cross sections perpendicular to the x-axis are squares. So I'll just draw myself in a little square here. The area of that cross section should be the side length squared, because it's a square. And that side length ought to be F minus G. So all we need to do is go in and integrate from A to 2 of F minus G squared. And that should have come out to be about 1.28. Everybody good there with that one? And this was 3 points here. That was really generous of them there. 3 points, 2 for this, and 1 for the answer. Any questions on part B? All right, and part C. So part C says H is the vertical distance between the graphs of F and G in region S. We want to find the rate of change with respect to X of H when X is 1.8. So first off, we'd want to go in and say something like H of X is F of X minus G of X. Okay. And if we are asked to find the rate at which H changes, what is the rate at which that function h changes? How do we define a rate at which a function changes?
Derivative.
The derivative. So we are looking at h prime of x, which should be f prime of x minus g prime of x. And if we want h prime of 1.5, what was it, 1.8? 1.8, I think, right? 1.8. That should just be f prime of 1.8 minus g prime of 1.8. And so you'll just use the derivative function on your calculator to evaluate the derivative of f at 1.8, the derivative of g at 1.8, and find the difference between them. And should have come out to be negative 3.812. And in this one, they gave a point for the final answer and a point for appropriately figuring out what h prime should be equal to. Or not, I mean, even if you got the wrong value for h prime, they really gave you the point for just trying to figure out what h prime was. So even if you, for some reason, couldn't get h prime was f prime minus g prime, if you wrote down h prime equals the rate of change of h, they probably would have given you that point. So just the idea that the rate of change of h is the derivative of h was what they were looking for that first point. And then manually being able to do it to figure out the value at 1.8 with the right functions in your calculator was the second point. Does that make sense? Any questions there on that one? Okay, so we've got a bit of time. We've got two more questions here. Let's see. Yeah, we'll probably have time. I don't know. Would you guys rather just spend the 15 minutes on each one? We have enough time to do both of them, but then we just would have to go over them both tomorrow. Or would you rather go over one of them first and then just have to go over one tomorrow and do one by yourselves tonight?
I would rather go over one of them first.
Okay, perfect. So this is going to be the 2016 problem. And I believe this was non-calculator. I would have written that it was a calculator question, I think, if it was. So, all right, I will give you 15 minutes and then we'll go through this one and then I'll post the other one up for you guys to do tomorrow. So 15 minutes starting now, ready to go. So this is the 2016 free response question that had to do with volume. So the part A had nothing to do with area volume stuff. We're looking for the average value of the radius. Well, the radius is just this value r, 1/20th of 3 plus h squared, from h equals 0 to h equals 10. So if we're looking for the average value of some continuous function r, that's the mean value theorem for integrals. So part A should just be 1 over b minus a times the integral from a to b of our function, which was 1/20th of 3 plus h squared. dh. Right? 1 over b minus a times the integral from a to b of your function. That's the average value of a continuous function. This radius, it's a continuous function. Right? The radius is given by different values of h, which we could look at as x's and y's if we wanted to. But good or no? With the beginning of that being the setup for part A.
Yeah.
Okay. And so we could, if we wanted to, pull the 1/20th out of here, and we'd end up with 1 over 200, and then we integrate 3h plus h cubed over 3 from 0 to 10. giving us 1/200, 30 plus 1,000 thirds minus 0. And let's see, 30 would be, should be 90 thirds, right? So we got 1,090 thirds, or 1,090 over 600, which we could make into 109 over 60. And I believe they gave us units in this, so we want to make sure we put the units inches. So we'll say inches. Even though it didn't necessarily indicate that you need to say your units, put the units if there are units. So you should have got 1 point for having the right setup here with the integral, 1 point for having the right antiderivative, and 1 point for having the right final answer. Any questions there on part A?
So if you didn't put the 1/10 out in front, would you still get that first point, or was that first point?
You'd get 2 points. Yeah.
Okay. So with the mean value theorem for integrals, is it kind of just like a regular average where you kind of just sum up everything and then you're dividing it by 10? Which
I mean, that's
is that like
effectively what you're doing, sort of.
intuitive way to think about it?
Yeah, I mean, you're adding, but you're not adding 10 different things. You're adding an infinite
different
number of things across an interval of 10.
Interval of 10.
So you're
Okay.
dividing by the length of your interval.
Just trying to see if there's a more intuitive way to think about it.
Yeah, I mean, yeah, you could think of, I mean, you can think of it that way. You're dividing by 10 because that's the length of your interval, but it's not the same as a regular average because a regular average takes things at regular intervals. So one, you know, you have, you're summing together a bunch of things that have a unit length of 1 theoretically when you're finding the average normally. Whereas here you're summing together an infinite number of things with a unit length of effectively 0 and dividing it by the length of your interval. Does that make sense or no?
Yeah. I just gotta look that over.
Yeah, and anytime, and thing to be careful about, anytime it says find the average value of something, the average value of something is going to be the mean value theorem for integrals, if it's the average value of a function. But if they say things like the average rate of change, right, that's just slope. So just be careful, the difference between those. Sometimes they'll ask for average rate of change in some of the free response questions, and that's literally just slope. All right, part B. Any other questions on part A? Everybody good there?
Yeah.
Okay. So for part B, we're looking for just the volume of the funnel. So the volume of the funnel, this, if we take it cross sections perpendicular to H, to our H axis, we're going to get disks. So it should just be pi times the radius squared. So hopefully the volume part of this was actually fairly straightforward. Our volume should have been pi times the integral from 0 to 10 of that. And that radius is actually, I mean, it's given to us 1/20th of 3 plus h squared, right? Squared dh. And we can pull the 1/20th squared out if we want, making that pi over 400 times an integral from 0 to 10. Then we'll distribute that out, 9 plus 6h squared plus h to the 4th dh. And then we'll integrate. So pi over 400, 9h plus 2h cubed plus h to the 5th over 5 from 0 to 10. And that's going to give us 90 plus what, 2,000. What is that? That's 100,000 over 5, right? Which is plus 20,000 minus a 0. And so what is that? 22,090 pi over 400 or 2209 pi over 40 inches cubed. Good or no?
Good.
1 point for the correct setup, 1 point for the correct antiderivative, and 1 point for the correct final answer. Any other questions on part B there? All right, so part C moved away again from the area and volume. It says the funnel contains liquid that is draining from the bottom. At the instant when the height is 3, the radius is decreasing at this rate. At what instant, or at this instant, what is the rate of change of the height of the liquid with respect to time? So what are we trying to do here? What type of problem is this?
Like one of those derivative things. I forgot what it's called, but it's in like the applications of derivatives.
Yeah, it's a related rate. This is a related rate. It's an application of the derivative. So we are given the rate of change, and I'll write this over here, the rate of change of the radius, dr dt. Right, dr dt is equal to negative 1/5. Oops, wrong way. We are given h is equal to 3 at the time we're interested in. And we are looking for the rate of change of the height of the liquid. So we are looking for dh dt. So we're given all of those things. It's got nothing to do with volume. We just need to relate r to h, and we already have an equation to relate r to h, right? R is equal to, I forgot it again, 1/20th of 3 plus h squared, right? Everybody good there? So what is dr dt equal? Well, it's just the derivative of this with respect to t, which is 1/20th of 2h dh dt. And we should then be able to say that dr dt is negative 1/5. H is 3, and we should be able to solve that for dh dt. 6 over 20 is what, 3 over 10. So we got negative 1/5 equals 3/10 of dh dt. So multiply by 10, divide by 3, and we should get negative 2/3, and that's inches per second, I believe. Yeah, inches per second. Any questions on that one?
What was the score breakdown on this one?
So if you got to here, that's worth 2 points, so that you appropriately got dr dt and a 1/10 h dh dt. That was worth 2 points, and then 1 point for the final answer.
I got thanks.
A nice little flashback to applications of the derivative and some of the stuff we're going to be reviewing again soon. Any questions on that one?
Can you show part B quickly?
Sure.
Thank you.
If you have a question on it, just let me know.
Thank you.
No problem. All right. So we don't have time for you guys all to work through this one. But this is the one that I'm going to have you guys do tonight for your last little assignment. We'll talk about this one tomorrow before we take the quiz. We will stop there. I'll post, this will be up in the blank notes folder. I'll also just post this this problem in Google Classroom as well, so you can see it.